Greetings, everyone. Joseph Kursky here. I serve as a geographer with a career focus on supporting geographic information systems, or GIS, and spatial thinking throughout all levels and in all disciplines of education. Today, I would like to speak with you about why and how to use GIS as a part of international baccalaureate or IB programs. We will focus on Arcgis Online. Arcgis Online, a cloud-based geographic information system, or GIS, from ESRI, Environmental Systems Research, Inc., the organization I represent. Joining me is Mark Epstein of the California Environmental Technology Education Network. I've known Mark for several decades and can attest that Mark has been a true champion in bringing GIS to primary and secondary schools, teachers, and students over those decades, working with a variety of students, both demographically and at multiple grade levels throughout California. Shortly before the COVID pandemic, the International Baccalaureate programs in Belgium adopted the use of Arcgis Online as an important component of its program. This action has been followed by other IB programs in Europe. Mark, from your experience working with K-12 education, primary and secondary, what makes GIS and Arcgis Online specifically so useful for IB programs?
The big benefit of using Arcgis Online in the IB programs is it enhances instructional strategies and philosophy of IB. It does that as a tool to acquire geographic data, analyze the data, and present the data. The Arcgis Online system fits very well to meet the student needs and progress both in the IB, middle years, and diploma programs. This can be applied across the IB curriculum, not just IB geography.
Let's set the stage. Many of you in IB programs may not be aware of Arcgis Online or even GIS, or Geographic Information Systems. GIS has as its primary goal to improve decision making in health, transportation, city planning, natural resource management, energy, public safety, and in many other disciplines by combining smart maps, spatial analysis, and spatial thinking. Modern GIS allows the user to go beyond stagnant, static maps and use the data interactively in the form of web maps, web mapping applications, and field tools. There are two ways to define a GIS: as a decision-making system where people use smart maps to make smart decisions, and also as a set of 5 components: hardware, software, methods, data, and people. Just like other cloud-based tools you use nowadays to work on shared documents or to access your music, modern GIS is cloud-based. Cloud-based GIS means that there's nothing to install, and you and your students can use it anywhere, with any device, at any time, in face-to-face, hybrid, or online teaching environments. It means that the data, the spatial data, maps, images, layers, are streamed as services, so you don't have to download them or use them on some sort of disk. It means that you can use maps online, and you can also create and share your own maps. You can create multimedia web maps, such as story maps, which we'll talk about. You can collect data in the field with an ordinary smartphone, map it, and analyze it. Through modern GIS, maps are becoming the language of the planet to communicate and to solve problems. Now, why use GIS in education? As an educator, you cannot and should not use any set of technologies just because they exist, right, folks? In my judgment, geotechnologies have merit in education for several key reasons. One focus of the IB program is to explore 21st century issues, all of the key 21st century issues on our planet, from natural hazards, pandemics, migration, biodiversity loss, climate, political instability, ocean acidification, soil, air, and water pollution, and many more, have a spatial component. They're all spatial. They're all multidisciplinary. They all exist at multiple scales. All of these issues are complex, right? And hence, the use of GIS enables students to better visualize and understand these issues. GIS encourages students to think spatially, to think critically, to develop data fluency, to solve problems, to connect with real issues, and to empower them, yes, empower them to become change agents in society, change agents. Many of the issues IB students are examining are related to creating a more sustainable world. Maps are becoming, again, the language of the planet to communicate and solve problems. Let's take a look at some of the capabilities that are at an IB teacher's fingertips to provide IB students with these tools. You've all seen this JHU COVID dashboard, and for good reason. It's very useful. People use it to make daily decisions. You've all used fitness apps or used mapping tools to navigate to the public library across campus or to a friend's house. You've all examined real-time weather or wildfires maps. Why? Because these maps and data sets are useful in your everyday lives. These are examples of modern web-based GIS in action. Mark, in your experience with students in K-12, how has the Arcgis system improved student success in learning?
When I entered education, I was primarily teaching earth science. I considered the purpose of teaching earth science was for students to understand the interactions of various earth systems. GIS does an excellent job of this as providing the ability for students to visualize different systems in a variety of ways and different scales. With the interactivity of Arcgis Online, students can change how data appears in different map layers and different data layer combinations, improving the meaning of the data and asking questions. The nature of Arcgis Online, with the immediate ability to change the appearance on the screen, increases student engagement in the topic. Using my experience from teaching earth science as an example, this technology allows students to inquire and experiment in the same way as earth scientists use computer models to make conclusions about the functioning of our Earth system. Across all subject content areas, Arcgis Online improves the student's ability to look at problems and can consider potential solutions using the same tools that are used to do the same in the professional world, leading to better career preparation. The Arcgis Online system also allows students to present their data and digital maps in a variety of formats that integrate well with other electronic media tools, improving their communication skills. We have a program called the Teenage Geospatial Action Program that has allowed many students the opportunity to work in the community to collect data, process that data, and present that data as part of projects in partnership with community organizations for the benefit of the community. The use of GIS, and today in particular with WebGIS, such as the Arcgis Online system, being easily accessible and applicable to teachers and students, results in improving inquiry and critical thinking skills. Most teachers today cannot imagine a classroom without an internet search engine or digital presentations. In the same way, those teachers who are aware of WebGIS and use it in instruction cannot imagine their classrooms without it.
Mark is touching on what I believe to be the core elements that are essential to success with GIS in education. One, systems thinking, examining the lithosphere, the hydrosphere, the biosphere, the atmosphere, the anthrosphere, the human sphere. This also includes teaching about cycles, the carbon cycle, the hydrologic cycle, and others, holistically. Scale matters. It has to do with patterns and relationships at different scales from local to global. Also thinking about the world as represented by map and data layers. And fourth, data fluency. And fifth, asking questions. Asking questions is really the most important part of being successful with geographic information systems technology. Now, why are educators interested in using GIS in their classrooms? We touched a bit on this earlier, but to summarize, engaged students, students that care, students as scientists, problem-based learning, working with professional tools. These tools are used in the professional workplace. Connection to community issues and people. Field work, geoliteracy. Think of geoliteracy as a three-legged stool that includes content, skills, and perspectives. Using GIS in education is never just about the skills or the buttons. Eighth, communication. your students can communicate the results of their investigations with these maps and tools. And ninth, geographic and scientific inquiry. GIS has been and always will be a thinker's tool. The most important tool in the GIS toolset is not buffering, overlay, or geocoding, or anything else that we do inside a GIS set of software, but rather your brain, the student's brain. That is the most important tool of all. Now, why GIS in IB? Educators can use it for instruction, research, and reporting via multimedia interactive presentations. Students use it for research, learning, and communicating, for example, with story maps or dashboards. GIS aligns well with the IB goal of developing students who can synthesize information and think critically.
The use of GIS can enhance student understanding of core IB content as related to geographic themes, including fresh water, oceans and coastal margins, extreme environments, geophysical hazards, leisure, tourism and sport, food and health, and urban environments. GIS is used by scientists, policymakers, and others in these fields on a daily basis. The use of GIS can enhance student understanding of core IB geographic perspectives across the content areas, including global change, population distribution, changing population, global climate, vulnerability and resilience, global resource consumption and security. GIS is a key tool to build global understanding, resilience, and sustainability. GIS aligns well with core IB goals of first encouraging the systemic and critical study of human experience and behavior, physical, economic, and social environments, the history and development of social and cultural institutions. Second, developing in the student the capacity to identify, to analyze critically, and to evaluate theories, concepts, and arguments about the nature and activities of the individual and society. Third, enabling the student to collect, describe, and analyze data used in studies of society to test hypotheses and interpret complex data and source material. Fourth, promoting the appreciation of the way in which learning is relevant to both the culture in which the student lives and the culture of other societies. Fifth, developing an awareness in the student that human attitudes and opinions are widely diverse and that a study of society requires an appreciation of such diversity. Sixth, enabling the student to recognize that the content and methodologies of the subjects in the individuals and societies groups are contestable and that their study requires the toleration of uncertainty. The use of GIS also aligns well with the IB geography key aims that apply across all the subject contents, including 1. Developing an understanding of the dynamic interrelationships between people, places, spaces, and the environment at different scales. 2. Developing a critical awareness and consider complexity thinking in the context of the nexus of geographic issues, including acquiring an in-depth understanding of how geographic issues or wicked problems have been shaped by powerful human and physical processes, synthesizing diverse geographic knowledge in order to form viewpoints about how these issues could be resolved. 3. Understanding and evaluating the need for planning and sustainable development through the management of resources of varying scales. GIS also meshes well with the creativity, activity, service, CAS experience of IB. GIS and CAS are both about identifying trends and patterns between individuals, societies, and processes, and how these may manifest in local, regional, or global issues. The field tools and place and space foundations of GIS lend themselves well to service to the community. GIS is about data and location, and each of those have critical ethical components and thus also well connected to core IB tenets. GIS is also well connected to the core components of the IB Middle Years program.
Thanks, Mark. Those are really good examples of using ArcGIS Online with students. They demonstrate how ArcGIS Online fits into the IB program and why the IB programs in Belgium and elsewhere made the decision to include ArcGIS Online as a major component of their programs. As you demonstrated in your experiences, GIS can become important to assist in instruction and for students to use as a research and reporting presentation tool. This substantially aligns to the IB program goal of developing students who can synthesize information and think critically. Let's look more specifically at 3 ways in which GIS can be used with some demonstrations. First, to teach content. Here are a few story maps that feature in-depth content. Hot numbers about climate change. Investigating the Titanic, where it sailed, who was on board, where they were from, first class, second class, third class, where it sank, etc. Spatial thinking about a historical event. Now, both of these, the hot numbers climate change story map and the Titanic story map, are content rich, would you not agree? Compelling stories that are enriched by maps and visualizations. Maps have been used to tell stories for thousands of years. No different nowadays, folks, but now we've got this, and you have this rich, interactive set of maps and data to teach with, to investigate problems, issues, concerns, as well as historical events. Using GIS can aid in teaching the following 3 areas, just as 3 examples: population, demographics, and population change. Ecoregions, mean annual precipitation, landforms, and how those 3 things interact. Natural hazards, earthquakes in 2D and 3D. What about GIS as a research tool? Let's examine the Living Atlas of the World, Survey 123, and ArcGIS Online. Let's take a look at how and what ArcGIS Online does. First, let's look at access to data. Like search engines, ArcGIS Online includes a search component by topic. Here's an example of a search of shared maps and data layers. We're going to focus on demographics of California by county. Like any search, students will be needing to be mindful of the sources of the data, understand where the data came from, who created it, how often it was updated, not just accept it because it's on the web, or not just accept it because it's a map, but actually be critical of all data, including, and I would argue, especially mapped data. Within the ArcGIS Online resource, there is a subset of authoritative maps and data layers in the Living Atlas of the World. It has 8,500 data entries in it. Let's take a look at the Living Atlas right now. For inquiry and greater analysis, students will be looking to compare data layers. This can be done in the ArcGIS Online Map Viewer. The Map Viewer accesses about 2 million data layers that students can display and can compare to develop conclusions. Here's an example showing wildfires and population density. Beyond the layers that are available, students can import data from other websites, or they can collect and create data in spreadsheets once properly formatted. ArcGIS Online also has the ability to set up a data collection survey that can be used to collect through crowdsourcing or actual physical collection and record on their smartphones, including data in the field, tree species, historical homes, noise, public art, litter, water quality, number of pedestrians at intersections, etc., plus images taken at those collection sites. Here, students and faculty collected, mapped, and analyzed storm drains using these tools and connected it to field trips to the local water authority and explored the connections to the natural world, watersheds, river systems, and the human-built world, city infrastructure. Let's examine GIS as a presentation and assessment tool. The resulting map products that students create are simply housed in a URL that can be shared with the instructor or with the entire class or with the entire school. Students can refine and update their maps after receiving input and advice from their peers and their instructor. They become part of the student's professional portfolio, even while they're still students. There are a number of ways that students can use ArcGIS Online to display what they have learned or reported on. This process fits in well, again, with the IB project and design strategies. The simplest is in the form of a web map with the layers that the students have created. Here's an example of this. The second way students can create a display is using story maps with components in story maps known as express maps. This tool creates a WebGIS product that includes maps, either created in the Story Map Builder or linking to web maps that they create in ArcGIS Online. Here's one of those maps right here. Story maps have a rich set of options to add text and images. Let's take a look at one of my favorite story maps, and this is the Dolores Huerta story map with an express map inside of it. The third option is to use the presentation mode. Think of the presentation mode as like PowerPoint, but each slide is an interactive web map with a title. The fourth option is to use WebGIS applications known as instant apps. Here's one of them right here. So to assess student work, these tools can be assessed in a variety of ways, including students create the web map or a story map and email or post the URL to their instructor, who then assesses the work. Students create web maps or story maps and email or post the URL to the entire class, who review each other's work along with a review from the instructor. And third, students can create web maps or story maps and present it in a video or live online or face-to-face to their peers and to their instructor. The instructor assesses the map and the presentation using some sort of rubric.
As part of that assessment process, many of your students, when they become comfortable and confident in using ArcGIS Online, may want to take the opportunity to participate in the annual Story Map competition. This competition was held in many states in 2021, and the winner of each state competition competes in the national competition. Each state competition division, first through fifth place, is awarded a $100 cash prize. The national winners in each division attend the Esri National GIS User Conference in San Diego, California, with travel expenses paid.
Yes, let's look briefly at student work with GIS. Here are a few of my favorites. First of all, the Silverdale Baptist Academy UAV story map from a student in Tennessee. I love how this student integrated UAVs that the student actually flew, or drones, and created a web map of the campus from that data. So interacted with the campus facility managers because they needed that data as well. It's a very nice integration of a variety of different tools, including imagery from drones. I also like this right whales story map from a student in Canada. This middle school student created this story map to analyze what's the problem of these right whales dying, why should we care about it, and also I really like how the student integrated maps, images, did some research, and at the end, this relates to the geographic inquiry process, the student actually presented why this actually matters, and here is a solution. In other words, a lot of these whales were getting trapped in lobster nets. How can we redesign these nets so that the whales wouldn't get trapped in them? I love that. And finally, this student's map from an outbreak of Legionnaire's disease in Minnesota is a very effective use of spatial analysis tools and story maps. Again, a real world problem, a real issue, a community issue, and the students were grappling with it and engaged with solving a problem. Mark, I know that you have worked with students for many years as well, and that you've got good examples to share with us as well.
Yes, I have two good examples. The first is from a couple of middle school students on a project working with a member of the Sacramento City Council that they submitted and won first place in the California Story Map competition. Here they were looking at a commercial corridor that has been deteriorating. They conducted a survey of the conditions in this corridor of the various commercial centers, and using that information made recommendations on a number of sites to be converted to affordable multi-residential housing. The second is a project with the California State Parks North Coast District to create an interactive map of the trail system to include interpretation of identified locations along the trail. This web application has been linked to the park website. We see that the Arcgis online system enables students to create a number of different types of digital map products and discuss how this technology relates to IB instruction. I am certain that our viewers are interested in learning a little bit more about the specifics of the tools.
ArcGIS is a family of GIS software that includes ArcGIS Online, developed by Esri, which is the organization I serve under as education manager. Well, what's Esri and what are our primary three goals? Why do we care about working with educators, for example? Our three goals are education, sustainability, and science. And that's been our goals since 1969. So we're actually a pretty old software company. We're older than Google, we're older than Microsoft, we're older than Apple. And Esri software is used around the world in a variety of professions, including education, public safety, natural resources, city planning, and many others I mentioned earlier. Sectors that use ArcGIS include government, nonprofit, academia, and industry. Fields in which ArcGIS is used includes those that I just mentioned and also those that you see here. Virtually every known field, because at some point, everyone is asking the whys of where questions. The ArcGIS online system is the easiest form of ArcGIS and GIS software in general to use in the primary and secondary classroom. The advantages of ArcGIS Online is that it is substantial in capabilities and is a stable infrastructure. It will be here in the future. Millions of people depend on it. It's supported by free software with a community of users and GIS professionals and geo mentors. In other words, you are not in this alone. You are not in this alone. Mark, let me ask you, from your work with students and the teachers, what tools seem to be the most utilized?
I would say the tool most used by students is the map viewer in order to access data layers. I would say students' second most function is the on-screen digitizing to draw lines and areas. Teachers, in particular science teachers, like having the students create data with specific location of latitude and longitude in spreadsheets and import that data into the map viewer. Since the development of the Express story maps, this has become a tool that teachers like to integrate geography with writing. The ease of use in utilizing the story maps over the classic story maps, now known as apps, has greatly increased the applicability for students to use ArcGIS Online to create presentations. One of the things I would encourage the IB programs to consider is participation in the story map competition. In California, that competition is sponsored by the California Geographic Alliance. I am certain that there are many student projects already part of the IB requirements in individual school sites that would easily fit and make good competition entries.
That is excellent, Mark. To begin, including the use of ArcGIS Online into IB programs should be an easy task. If you need assistance, Esri helps support a network of mentors like Mark, along with many other resources, some of which we've detailed here. But we just invite you to start on that pathway of using these interactive map-based tools to foster teaching and learning. Well, thank you, Mark, for sharing with us today. I trust the listeners will be inspired to pursue at least some of what we've discussed, and we encourage you to do so, and we are here to support you.